20 degrees is less than sine 40 degrees. So while we can't actually necessarily get the exact measurement of these values, we can kind of compare where they are. And we can also tell another thing. We can realize that because it's in the first quadrant, the sine value can only be between 0 and 1. So another comparison we can make is that these values are between 0 and 1. What's another thing we can do? Now let's think we need to now deal with the tangent problem. So when we look at tangent 245, tangent 230, we'll recognize that it's in the third quadrant, because third quadrant is between 180 degrees and 270 degrees. Now what's something that we'll notice about tangent? Something easy to think about tangent is there's a point where it's equal to 1, because tangent is just sine over cosine, or in the case of when we talk about a unit circle, it's just y over x. So it's just a ratio between sine and cosine. And if we think about when sine and cosine is equal to each other, that's always 45 degrees. So it looks something like this. But at 45 degrees in the third quadrant, that's 45 plus the 80, with the 180. So we get that this is actually 225 degrees. Now let's think about how this ratio works, right? That means, so if we go to the right of 225 degrees, what happens is the y value keeps increasing while the x value is decreasing. When we look at this ratio, well, if the y value increases and x decreases, then tangent should be increasing larger and larger to essentially infinity. Now on the other hand, if we go to the left side, we realize that y gets smaller and x gets bigger. So that means the point gets smaller and smaller until it approaches 0. So we have these two types of relationships that we made. Now let's see how 230 and 245 compare. Well, 230 is just a little past 225 degrees, and 245 degrees is past that. So knowing that if we go further, we get a bigger tangent value, we know that tangent 245 is actually a bigger value. So we can say tangent 230 degrees is less than tangent of 245 degrees. Now, the question is, can we compare this with the sine values in some way? Well, we can. We know that tangent, these two values are past the 225 degree point. In other words, it's greater than 1. What else do we know? Well, it's anywhere between this 1 to infinity, so we can say that it's bounded between 1 and infinity. Now, if we kind of look at this in comparison to this function, we recognize that, well, it kind of relates with how we restricted the domain, right? 0 through 1 being this part, and 1 through infinity kind of relating with this part. So let's think about this relationship, right? We see that this is strictly decreasing. So if we get further away, if we're looking between 0 and 1, and we get further away from 0, we get a lower value. So in other words, if we try to compare a function of sine 20 degrees and function of sine 40 degrees, because sine 40 degrees is actually a bigger value, it's going to be further away, giving me a more negative value. So if we actually compare these, function of sine 20 degrees is actually the bigger value. The next problem we need to deal with is tangent 230 degrees and tangent 245 degrees. Now, if we look at this, this is also strictly decreasing. So if we see that whichever value is less, it's actually going to give us a bigger value. In this case, that means tangent 230 degrees is bigger than function of tangent 245 degrees. Now the question is, how do we compare these values? Well, we noticed that all these values between 0 and 1 were negative, while all the values from 1 to infinity were positive. That means these values are actually bigger than these. So we can say that this is going to be greater than these values, right? So we can say something like this. Now, if we try to complete this, then we can say that f sine 40 degrees, or in this case, d, is going to be the smallest value. Then we have c. Then we have that tangent 245 degrees is smaller. And then the biggest value is going to be function of tangent 230 degrees. Okay, so whenever we deal with these type of problems, right, this problem at first might have seemed a little daunting right? But it's actually very easy. We don't have to use any difficult concepts. There's no calculus here. There's not even any pre-calculus really here, right? The only thing that you really need to understand is geometry, functions, and from there you can generally solve this problem. And this is the same way we want to deal with any type of SAT problem. None of them are going to be very difficult conceptually, but we want to be able to break down the problem, understand the information that's given to us, and then finally reach the answer that we're looking for. Now, if you have any questions about this problem, or if you have any questions in general, feel free to leave them in the comments. And please visit us at chicagobread.com to learn more about kind of how we approach standardized tests and just learning in general.